Assalamualaikum and very good day to all of you. So today we're gonna continue our part 3 for chapter 4, okay, on the topics of general energy equation. In this part, okay, for part 3, we will learn how can we compute the power and efficiency of pumps and fluid motors, okay. So it still relates with the general equation of energy, but it's more focusing on the power and efficiency. Okay, so how can we calculate power which is required by pumps? Okay, so in the previous part 2 video, okay, we know that pump is function to add the energy to the fluid flow system. So how much the power needed in order to provide that particular energy? Okay, so basically we know that power is defined as a rate of doing a certain work. Okay, so the fluid in terms of fluid mechanics, okay, the rate in which that the energy is being transferred from the device to the fluid flow system. Okay, and in order to calculate power, we can use this formula in which that, okay, P is actually the power that we want to calculate, and H is actually the amount of energy added. Okay, this one we already covered in previous part, okay, part 2 and part 1, okay, the energy added, okay. And W is actually defined as wake flow rate. Okay, so wake flow rate, we know that we can calculate the wake flow rate based on this formula, in which that the wire here is actually a specific wake, okay, and the Q is actually the flow rate, okay, and therefore, this equation can also be rewrite into this equation, okay, in which that the terms of W here can be replaced by using this term. Okay, and what about the unit for power? Okay, the unit for power is defined as watt, okay, or maybe if the value is too big, the magnitude is too big, maybe we can use the kilowatt or megawatt, okay, depends on the magnitude value. Alright, so apart from power, we may also need to calculate the efficiency of a pump. So what is the efficiency of a pump? Okay, so for example that you plug a pump to electrical resources, okay, so for example this is a pump, okay, you plug it to electric resources, okay, in which that is stated on the pump, which is that the pump is operated at 200 kilowatt, for example, okay. But however, okay, when this pump is being used to deliver fluid from point A to point B, and through calculation we calculate that what is the power output, okay, from the pump. And for example, like according to your calculation, the power output, maybe it only gives you around 150 kilowatt, okay. So what is the efficiency of a pump? Okay, so that's why it is important for us to know what is the efficiency of pump by dividing between the actual power, which is this one, P actual divided by P resource, okay, and then and this is the efficiency of a pump, okay. Okay, this is the formula that I mentioned just now, okay. So this one is actually the actual power delivered by a pump, okay, divided by power input into a pump, okay. So the reason behind it, why we have to calculate it, because there might be a tendency of energy losses during the process of transporting or moving a fluid from one point to another point, which is might be due to the mechanical friction, fluid friction, and maybe excessive fluid turbulence inside pump, okay. And the value of EM is always should be less than 1.0, and the mechanical efficiency of a pump, basically it totally it can be depend on a few parameters. Okay, so one of it, okay, which is that the operating condition of a pump, which is total head and flow rate of the pump. Okay, so these are the factor which is strongly influence the value of efficiency for a pump. Okay, just now we learn how can we calculate the power which is added to a pump, but in this case we will calculate how can we determine the power delivered to a fluid motors. Okay, so we know that before this, fluid motor is actually device to remove or to move power, or sorry, to move energy inside the fluid flow system. Okay, so again, the power removed from a fluid by a motor or turbine can be calculated by using this formula. Okay, so if you still remember, this is the HR, which is the energy removed, okay, from the fluid flow system. Okay, we already covered these things in in part 1 and part 2 from this chapter 4. Okay, so again, W is the same thing as well, which is the wake flow rate, in which that we can also express it in this term. Okay, this one is actually represent the W. Okay, so same goes to the one that we determined before, in which that not all the power delivered to the motors. Okay, and there might be a tendency that of the energy losses, okay, happen inside the system, so that might be a loss a bit on the energy, which is reduce the amount of power removed. Okay, so that's why we can also calculate the efficiency of the fluid motors by using this formula, which is that the ratio of the power output from the motor divided by power delivered by the fluid. Okay, so this is the formula to calculate the efficiency of the motor. Okay, let's try to solve this question. Okay, so based on the question, it mentioned that the water at 10 degrees C is flowing at a rate of 115 liquid per liter per minute. Okay, so and then it is flow through a motor here. Okay, in which that the pressure at A equals to 700 kilopascal, and the pressure at B, which is 1 to 5 kilopascal. Okay, and it is estimated that the energy loss from the friction inside pipe, okay, which is 4 Newton meter per Newton, which is this one is actually the HL value. Okay, and it is known that the outside diameter is 25 millimeter and the thickness is 2 millimeter. Okay, at this point the outside diameter is actually 25 millimeter and the thickness at A is actually 2 millimeter. Okay, meanwhile at point B, okay, the outside diameter is actually 75 millimeter and then the thickness at B here is 2.8 millimeter. So from the question here, is required for us to determine what is calculate the power delivered to the fluid motor. Okay, so the power delivered by fluid motor, which is PR. Okay, and then for question B, it requires us to calculate what is the power output if the efficiency in this case is 85%. Okay, so let's check it out. How can we strategically plan to solve this problem? Okay, so let's take a look how can we solve the problem. Okay, so this is the diagram which is given from the question, And as usual, the first step is you should extract the information given from the diagram and also from the question. Okay, so at point A, okay, the question already give us about the QA and PA, in which that the QA, the flow rate at that condition at that point is 115 liter per minute, and the pressure at point A is 700. And it also provide the dimension of the pipe consists at A, which is at this point. Okay, this is the pipeline here. So this is the specification in which that the outside diameter is 25 millimeter, and then because it's given the outside diameter, so it also provides us with the wall thickness. Okay, so be careful with this information, because that the area, the flow rate area that we are looking for is actually for the inside layer here. So we are looking actually the inside diameter here, but it didn't provide us the inside diameter, it just gave us the outside diameter and the thickness. However, you can get this information by using information about the outside diameter and the wall thickness. Okay, and the wall thickness is actually on one side. On each side is 2 meter. Okay, and it also provides us information at B, which is at point B, the pressure is 125 kilopascal, and the dimension of the pipe at B, okay, at this point is actually the diameter, outside diameter is 75 millimeter, and the thickness for each side is actually 2.8 millimeter. Okay, it may look like this, in which that the outside diameter, okay, outside diameter is given by this value, and the thickness for each point here, so this is the thickness value. Okay, and it also provides us the energy loss due to the friction of inside the device, and also friction due to the fluid inside the system, which is the value is 4 Newton meter per Newton. And we need to determine what is the power removed by this fluid motor. Okay, so this is the formula that we can use to calculate the PR. Okay, but actually this one is the initial formula that we can use to determine the HR. So from HR we can determine the PR, in which that the PR is actually equals to HR times with the work done, okay, which is work equals to specific weight times with the flow rate. Okay, so there are two formulas that we can use. The first one is the general energy equation, okay, and the second one, okay, once you get the HR value, you have to calculate the power removed by the system by using this formula. Okay, so since we know that this system doesn't consist of a pump, so we remove this HA. Okay, and HL is already provided, okay, which is 4. Okay, so all other information can be determined by using information provided in here, which is the QA can be used to determine the VA and VB. Okay, sorry, the notation here I should change. Okay, this one will be PA, ZA, VA, and also PB, ZB, and VB. Okay, so our aim is we want to calculate what is the HR first. Okay, then from the HR we can calculate the PR value by using HR times with the W. Okay, alright, so therefore we can conclude that, okay, this is the formula that we're gonna use for energy equation. Okay, by knowing that we need to determine the HR, and then the HA value can be cancelled because this question or this problem didn't involve the addition of energy. It just involved the removal of energy and then the HL, the losses of energy. Okay? And therefore, I can rewrite the first equation into this form since that we want to calculate the HR. Okay, so once you already got the HR, so this HR value we can use to calculate the power value, in which that the HR can be substituted into this equation. Right, so about this term, okay, most of the information is already provided in the question, which is the pressure at both points is given, okay, and the elevation difference between the point A and point B is also given. And about the VA and VB, actually we can get this value because the question provides us about the flow rate, and the HL also given in the question. And to calculate the VA and VB, we can use the equation 3 here, in which that this one is the concept of continuity equation. So before we can determine the VA and VB term from the continuity equation, we need to find first what is the flow rate area. Okay, so for example, at point A, okay, we know that from the question is stated that it has a diameter, the outside diameter, okay, and then the thickness of the wall is given, which is 2 millimeter. Okay, so in order to calculate the area, the flow rate area, we have to use this equation. Okay, however, be careful with the terms D here. Okay, the D here should be the inner diameter, in which that in order to calculate the inner diameter, you have to deduct the value of the thickness. Okay, so imagine that this is a pipe. Okay, it provide this is the inner diameter. Okay, but the question only provide us the outside diameter at this line. Okay, outside diameter. Okay, so we need to deduct this thickness, the thickness here and the thickness here. So that's why the inner diameter is equals to outside diameter minus with the 2 times the thickness value. Okay, then we can get the area. Okay, and same goes to the AB, which is the value of the area is 3.78 times 10 to the power of minus 3. And for the area in A is 3.46 times 10 to the power of minus 4. And the unit is meter squared. And this one also meter squared. Okay, so once you already calculate the area, okay, you need to substitute into the equation of Bernoulli equation. Okay, sorry, it's not Bernoulli. This one is actually using the continuity equation, which is QA equals to QB, which is VA times AA and equals to VB times AB. Okay, so since the area is already obtained from the previous step, okay, so we need to get what is the VA and VB. Okay, so here we already have the Q, but you have to change the unit first because the unit given originally in the question is liter per minute. Okay, so here I change it into SI unit, which is meter cube per second, 1.92. So since I already got the Q, okay, so I can calculate the VA, which is equals to QA divided by AA, and VB equals to QB divided by AB. So here is my AA value and VB value. And then these two terms, the VA and VB, I'm going to use it to calculate the terms inside here. Okay, so I just substitute the value, and this term is equals to 1.556 value. Alright, so next procedure is we will substitute all the value which is available either from calculation or from the value given from the question inside this formula. Okay, so here I substitute the term here let's say that this is a term 1, okay, which is 58.6, okay, and this is the term number 2, which is 1.8, and this is term number 3, which is 1.556, and term number 4, which is the losses, we got this information from the question, which is 4 meter. Okay, so once you substitute all the value, you manage to get the value of HR, which is 57.96. Okay, so since the HR is already obtained, then we can calculate the PR value, which can be substituted directly into this equation. Okay, so this is our PR value, which is 1091.7 watt, or maybe you can also write it down as 1.091 kilowatt. Okay, sorry, let me write it clearly. So the value is actually, if we want to derive it in kilowatt, it should be 1.0917 kilowatt. Okay, that's it. Okay, so for question B is very simple, in which that the question asks us to determine what is the power output by the motor. Okay, and it is given that the mechanical efficiency of that motor is 85%. Okay, so knowing that the mechanical efficiency can be determined by using this formula. Okay, so our aim is we want to know this value, and the EM is given, okay, and the power which is delivered by fluid actually can be get from question A, because just now we calculate the PR, okay, the power removal. Okay, so we know that the PR from calculate from A is actually 1091.7 watt, okay, and the efficiency is 85%. Okay, so then we can calculate the value of power output, okay, which is 927.94 watt. Okay, that's it. Thank you. Okay, this is the end of chapter 4. Thank you very much.